The objectives for this video are to learn the characteristics of the F distribution and to find the critical value for a hypothesis test about the difference between population variances. Household incomes for random samples of 22 counties in Texas and 20 counties in Alabama were averaged and recorded. The variances for the sample means are shown below. Can it be concluded at a 0.05 level of significance that a difference exists in the population variances for the two states? In order to conduct this hypothesis test, we will use the F distribution. The characteristics of the F distribution are: 1. The values of F cannot be negative because variances are always positive or 0. 2. The distribution is positively skewed. 3. The mean of F is approximately equal to 1. 4. The F distribution is a family of curves based on the degrees of freedom of the variance of the numerator and the degrees of freedom of the variance of the denominator. Step 1 for this hypothesis test will be to state the hypotheses. Recall that equals always occurs in the null hypothesis, so the null hypothesis will be sigma 1 squared equal to sigma 2 squared. Since we are asked to draw a conclusion about whether or not a difference exists in the population variances, the alternative hypothesis will be sigma 1 squared not equal to sigma 2 squared. Step 2 will be to find the critical value. In order to find the critical value, we will need to understand a bit about the formula for the F-test. The formula for calculating the F-test value is to divide the sample variance for group 1 by the sample variance for group 2, where the larger of the two variances is placed in the numerator regardless of the subscripts. Looking at our statistics, we can see that Texas will have the larger variance. Therefore, group 1 will be Texas, and group 2 will be Alabama. The F-test has two values for the degrees of freedom, that of the numerator, n1 minus 1, and that of the denominator, n2 minus 1, where n1 is the sample size from which the larger variance was obtained. So the degrees of freedom for the numerator will be n1 minus 1, where Texas represents group 1, so the number of degrees of freedom for the numerator will be 21. The degrees of freedom for the denominator then will be 19. The table is that of the F distribution for alpha equal to 0.025. Since the specified level of significance was 0.05, and this is a two-tailed test, we should use the F distribution table that is headed 0.025. Our degrees of freedom for the numerator is 21, but we see that this table does not contain a column for 21 degrees of freedom for the numerator. So we will go to the next smallest column, which will be for 20 degrees of freedom for the numerator. Our degrees of freedom for the denominator is 19. This column and this row intersect at the value 2.51, so our critical value will be 2.51. In this video, we learned the characteristics of the F distribution and how to find the critical value for a hypothesis test about the difference between population variances.